Welcome back to another deep space journey, presented exclusively for all the astronomy lovers here on the Dark Sky Dive channel. Floating in the cold vacuum of space lies the King of Planets, a gas giant that guards the solar system's secrets. For centuries, we have observed this massive world from afar, wondering what mysteries lie beneath those thick and turbulent cloud layers. It is a world so large that it could easily swallow every other planet in our solar system more than twice. But recently, a brave robotic explorer named Juno has dared to venture closer than any human-made object has ever gone. This mission was not just a visit, it was a calculated invasion into one of the most hostile environments in existence. Jupiter is surrounded by intense radiation belts that act like a deadly force field, capable of frying any ordinary electronic circuits. To survive this, engineers built a heavy titanium vault, essentially creating an armored tank designed to fly through deep space. Inside this 400-pound box, the spacecraft's brain is shielded from the high-energy particles that bombard it constantly. Juno spins to maintain stability, a delicate dance in the void that keeps its scientific instruments pointed at the giant planet. The mission profile requires a daredevil maneuver, diving in close to gather data and then quickly retreating to escape the radiation. These suicide dives bring the spacecraft within just a few thousand miles of the cloud tops, closer than ever before. Every second of these close encounters is precious, as Juno's sensors drink in information about the magnetic and gravitational fields. Using infrared vision, we can see through the upper haze, revealing the heat leaking from the deep interior of the planet. What Juno found at the poles shocked scientists, shattering our previous assumptions about how this gas giant's atmosphere actually works. Instead of bands, the poles are covered in clusters of cyclones, each one large enough to swallow the entire United States. At the North Pole, 8 distinct cyclones surround a central storm, forming a perfect octagon that defies all known explanation. Down at the South Pole, the geometry changes to a pentagon, a stable formation that has persisted for years without wavering. These storms rub against each other but do not merge, behaving like giant gears in a machine rather than chaotic weather. On the dark side of the planet, Juno's cameras captured lightning strikes that are far more powerful than anything on Earth. Scientists discovered shallow lightning originating high in the atmosphere, suggesting the presence of ammonia water clouds much higher than expected. This leads to the creation of mushballs, slushy hailstones made of ammonia and water that grow heavy and fall deep down. These toxic hailstones act like a conveyor belt, dragging ammonia from the upper atmosphere down into the crushing depths below. As we descend deeper, the concept of a surface becomes meaningless. There is no solid ground to stand on here. The atmosphere gradually thickens into a supercritical fluid, a state where distinct boundaries between gas and liquid completely disappear. Thousands of miles down, the hydrogen is crushed so hard it becomes a metal, capable of conducting electricity like copper. This churning ocean of metallic hydrogen acts as a massive dynamo, generating the most powerful planetary magnetic field in the system. Juno revealed that this magnetic field is lumpy and uneven, suggesting the dynamo is closer to the surface than thought. One particular anomaly stands out, a region scientists call the Great Blue Spot, where the magnetic field is strangely intense. This magnetic spot is being dragged by deep atmospheric winds, proving that Jupiter's weather reaches far deeper than we imagined. Returning to the visible surface, we cannot ignore the most iconic feature of Jupiter, the legendary Great Red Spot. For centuries, this storm was wide enough to swallow 3 Earths, but recent observations show it is shrinking at alarming rates. Juno's microwave radiometer measured the storm's depth, finding that its roots extend hundreds of miles down into the atmosphere. The roots of this storm are incredibly hot, feeding energy up to the surface and keeping the vortex spinning violently. We are witnessing flakes of the storm peeling away, leading some to speculate that the spot may disappear within our lifetime. If the current trend continues, this iconic red eye might vanish in the next 20 to 50 years, changing Jupiter forever. Perhaps the biggest surprise from Juno is the core itself, which is not a solid rock as textbooks have always taught. Instead, Jupiter has a fuzzy core, where heavy elements are diluted and spread out across a vast region of the center. To explain this, scientists proposed a violent theory, a head-on collision with another massive planetary embryo early in Jupiter's history. A planet 10 times the mass of Earth may have crashed into Jupiter, shattering its original compact core completely. This impact would have stirred the pot, mixing the heavy core materials with the lighter hydrogen envelope for billions of years. This suggests that Jupiter is a cannibal planet, having consumed its siblings to become the massive giant we see today. Back in the present, the Juno spacecraft is showing signs of age, battling the harsh environment that seeks to destroy it. Jupiter is not alone. It hosts a family of moons, including Europa, which is considered a prime candidate for alien life. To protect Europa from contamination by Earth microbes, NASA has decided to end the mission with a deliberate death dive. In 2025, Juno will fire its thrusters one last time, committing itself to the gravity of the gas giant. It will burn up like a meteor, becoming one with the planet it has spent its life studying and understanding. Its atoms will remain there forever, a permanent part of the king of planets, marking humanity's touch on the cosmos. From the diluted core to the ammonia rain, Juno has rewritten the textbooks and humbled us with the complexity of nature. Thank you for joining us on this deep dive. If you enjoyed this journey, please subscribe to Dark Sky Dive channel. Stay curious, keep looking up at the stars, and we will see you in the next video exploring the unknown universe. Next time, we might explore the icy moons and the hunt for life in the subsurface oceans of the outer system. Let us take a moment to appreciate the human ingenuity and years of labor that made this incredible mission possible. Every bolt and wire was placed with purpose, knowing that once it left Earth, there would be no second chances. Launched in 2011, it took 5 long years for Juno to traverse the vast distance to its target destination. It cruised through the cold silence, using Earth's gravity as a slingshot to gain the speed needed to reach Jupiter. Arrival was a nail-biting moment. A failure in the engine burn would have sent the spacecraft flying past uselessly. But the math was perfect, and Juno slipped into orbit, ready to begin its legacy of discovery and scientific revolution. The colors we see are chemical reactions, white ammonia clouds mixing with sulfur compounds that turn brown and red in sunlight. These bands are driven by jet streams moving at hundreds of miles per hour, tearing the atmosphere into distinct stripes. Juno captured the famous String of Pearls, a series of massive rotating storms that appear as white ovals on the planet. Each pearl is a massive storm, churning the atmosphere and creating updrafts that bring fresh material from the deep interior. We also see gravity waves, atmospheric ripples that reveal the dynamics of the fluid layers moving beneath the visible surface. Jupiter also possesses the most powerful auroras in the solar system, light shows that never stop dancing at the poles. Unlike Earth, these lights are fueled by volcanic particles from the moon Io, trapped and accelerated by the magnetic field. Juno flew directly through the electrical currents connecting Jupiter and its moons, listening to the eerie sounds of plasma waves. The spacecraft recorded the radio emissions, converting them into audio that sounds like a haunting alien chorus from the deep. The stability of the polar polygons is a puzzle. Computer models struggle to explain why the storms do not merge. Some physicists suggest the atmosphere behaves like a liquid crystal, creating geometric order out of the chaos of fluid motion. The central cyclone spins one way, while the surrounding storms spin the opposite, creating a buffer zone that maintains the shape. JunoCam, a camera added for the public, has provided some of the most artistic and breathtaking images of the mission. Citizen scientists around the world download the raw data, processing it to reveal details that professional teams might have missed. They have found whimsical shapes in the clouds, like the famous dolphins swimming through the turbulent ocean of gas. The atmosphere looks like a chaotic oil painting, a masterpiece of fluid dynamics created on a canvas 40,000 miles wide. Finding out how much water is in Jupiter tells us where the planet formed and how the solar system evolved. Juno found that water makes up about 0.25% of the atmosphere molecules, 3 times the sun's value. This enrichment suggests Jupiter devoured massive amounts of ice during its birth, possibly forming further out before migrating inward. The mushball mechanism explains why the upper atmosphere seemed to be missing ammonia. It is all being hidden deep below. Eventually, the mushballs melt in the deep heat, releasing their ammonia payload and creating a hidden reservoir of volatile gas. By measuring gravity, Juno proved that the colorful winds we see extend nearly 2,000 miles down into the planet. While Earth's weather is a thin skin, Jupiter's weather is a massive shell, comprising 1% of the planet's mass. Below this depth, the chaotic winds stop, and the planet rotates as a rigid body of conducting metallic hydrogen fluid. The intense magnetic field acts as a brake, freezing the fluids and preventing the surface winds from penetrating any deeper. The drift of the Great Blue Spot is the first direct evidence of deep atmospheric winds interacting with the magnetic field. We have witnessed secular variation, meaning the magnetic field is actively changing and evolving right before our electronic eyes. On Earth, these changes take centuries, but on Jupiter, the violent interior causes the field to shift in just years. This confirms that the Dynamo generation region is not deep in the core, but closer to the surface than expected. The fuzzy core may even be pulsating, causing subtle shifts in the gravitational field that Juno can detect with precision. Deep inside, helium may separate from hydrogen, falling as a neon rain that releases heat and alters the planet's structure. This helium rain creates friction, generating the excess heat that makes Jupiter glow brightly in infrared light telescopes. The Great Red Spot survives by feeding on smaller storms, absorbing their energy to keep its massive engine running smoothly. But recently, the supply of these snack storms has decreased, leaving the Great Red Spot starving and slowly losing momentum. Some scientists argue it might not vanish, but simply change shape, evolving into a more stable circular vortex over time. Juno also visited Ganymede, the solar system's largest moon, capturing detailed images of its icy and cratered ancient surface. It is the only moon with its own magnetic field, creating a mini magnetosphere nested inside Jupiter's massive one. Then there is Europa, an ice world that hides a global ocean containing twice as much water as all Earth's oceans. Juno searched for plumes of water venting into space, hoping to taste the ocean without ever touching the surface. In stark contrast, Io is a hellscape of volcanoes, the most geologically active body in our entire solar system. Juno peered into Loki Patera, a massive lava lake, mapping its heat distribution and revealing a crust of cooling magma. Io is caught in a gravitational tug-of-war, squeezed by Jupiter and the other moons until its rock melts. Originally planned to end sooner, the mission was extended, transforming Juno into an explorer of the entire Jovian system. Despite the radiation damage, the solar panels continue to generate enough power to keep the spacecraft and instruments alive. Navigation engineers perform miracles, tweaking the trajectory to thread the needle between radiation belts and moon orbits. From the south, the planet looks like a tapestry of circles, a view that no human eye had seen before Juno. We noticed a subtle asymmetry. The North Pole appears bluer, while the south is covered in a thicker, yellow haze. High above the main clouds, detached layers of haze float in the stratosphere, casting long shadows on the decks below. Juno often captures the sharp, black shadows of moons racing across the cloud tops, creating frequent solar eclipses below. Imagine floating in those clouds and watching the sun vanish behind Io, plunging the storm into a sudden, eerie twilight. The high concentration of heavy elements is the smoking gun, proving that Jupiter grew fat by consuming solid planetary bodies. Unlike Saturn, which likely has a distinct core, Jupiter's mixed interior points to a unique and violent cataclysmic event. Jupiter acts as a gravitational shield, absorbing or deflecting comets and asteroids that might otherwise threaten life on Earth. Conversely, it may have flung icy asteroids at the early Earth, delivering the water that now fills our oceans. It is the architect of the solar system. Its migration and gravity shaped the asteroid belt and stunted Mars's growth. Juno also studied the faint rings of Jupiter, dusty halos that are invisible from Earth without powerful telescopes. These rings are created by dust blasted off the small inner moons when they are struck by stray micrometeoroids. Tiny moons like Metis and Adrastea orbit within the rings, acting as shepherds that sculpt the dust into shape. There is a primal fear in seeing something so large, a feeling of megalophobia that Juno's images often evoke. Imagine the sound of winds blowing at 400 miles per hour, a constant, deafening roar that never ends. The white ovals are high-pressure systems, towering cooler clouds that rise above the surrounding darker and warmer layers. In the chaotic, folded filamentary regions, the clouds are whipped into frenzied patterns that defy any simple meteorological description. Juno was the first to detect Sprites and Elves on another world, fleeting flashes of light dancing high above storms. These are luminous electrical discharges triggered by lightning below, painting the upper atmosphere with brief rings of ultraviolet light. While Juno focuses on the planet, The upcoming JUICE mission from Europe will focus on the potential habitability of moons. Juno proved that solar power can work this far out, paving the way for future green energy missions to the outer planets. A mission like this spans careers. The people who designed Juno are now watching the next generation analyze its data. Sending data back is a slow process. It takes 45 minutes for the radio signal to travel to Earth. Giant antennas on Earth must listen carefully to catch the faint whisper of Juno's signal against the cosmic background noise. From a distance, it appears serene and static, a marble suspended in silence. But we know now that is a lie. Inside, it is a churning hellscape with temperatures hotter than the surface of the sun and pressures beyond imagination. The metallic hydrogen ocean is the key. Understanding it helps us understand not just Jupiter, but giant planets everywhere. We have found thousands of gas giants orbiting other stars. Studying Jupiter gives us the blueprint to understand them all. Some even speculate about life floating in the clouds, where temperatures are mild, though the radiation makes it unlikely. The real hope for life lies not in the clouds of the Father, but in the icy oceans of his children. From its launch in 2011 to its fiery end in 2025, Juno has been a triumph of engineering. The data collected will keep scientists busy for decades, long after the spacecraft itself has been vaporized into atoms. Juno has earned its place in the Hall of Fame of Exploration, alongside Voyager, Cassini, and the Mars rovers. When the final command is sent, there will be silence in the control room, a moment of mourning for our robot. Before it dies, it might take one last look back at Earth, the tiny blue dot where its journey began. We have learned that the universe is far more complex, violent, and beautiful than our simple models could ever predict. Jupiter will continue to spin in the darkness, guarding its remaining secrets until we return with new eyes and machines. This concludes the epic saga of the Juno mission, a story of daring exploration at the edge of the abyss. We hope this deep dive has sparked your imagination and expanded your understanding of our cosmic neighborhood. Support our channel by hitting that subscribe button and ringing the bell so you never miss a future documentary. If you are hungry for more space mysteries, click on one of the videos appearing on your screen right now. Thank you for watching Dark Sky Dive. Keep wondering, keep exploring, and goodbye until the next time. For those who want to go even deeper, let us spend some time analyzing the physics of these massive storms. We see classic fluid instabilities, like the Kelvin-Helmholtz waves, forming where two bands of wind shear passed each other. It is exactly the same physics that creates waves on the ocean when the wind blows, but on a planetary scale. We also observe vortex streets, trailing swirls that usually form behind islands on Earth, but here they form spontaneously. These storms are powered by the planet's internal heat, acting like a massive heat engine that converts thermal energy into motion. Moist convection plays a huge role. As water condenses, it releases latent heat that fuels the violent updrafts we see. On Earth, hurricanes die when they hit land, but on Jupiter, there is no solid surface to slow them down. Storms grow by merging. Smaller vortices are constantly being eaten by larger ones, transferring their energy up the chain. The red color likely comes from simple chemicals like ammonia and acetylene being cooked by ultraviolet sunlight in the upper atmosphere. The Great Red Spot is a cold, high-pressure mountain of gas, towering 5 miles above the surrounding cloud decks. Interestingly, while the storm shrinks, the winds at its outer edge are actually speeding up, spinning faster like a figure skater. Juno helped solve the mystery of the X-ray auroras, discovering that vibrations in the magnetic field lines cause the flares. When the solar wind hits Jupiter, it compresses the magnetosphere, triggering magnetic reconnection events that release massive amounts of energy. Jupiter's magnetic tail is so vast that it stretches all the way to the orbit of Saturn, completely invisible to us. Juno has flown through this magnetic wake, experiencing the chaotic turbulence of plasma trailing behind the giant planet. The spacecraft detected large amounts of trihydrogen cation, a molecule that plays a crucial role in cooling the planet's atmosphere. The gravity map Juno created is not smooth. It shows bumps and dips that reveal how mass is distributed deep inside. Jupiter exhibits differential rotation. The equator spins at a different speed than the poles, twisting the magnetic field lines. The massive rotation of Jupiter even drags the fabric of space-time around with it, a relativistic effect called frame dragging. The microwave radiometer allowed us to peel back the cloud layers like an onion, seeing the storm structure in 3D. We found a complex thermal sandwich. The storm is warm at the top, cold in the middle, and warm at the bottom. To put it in perspective, the entire Hurricane Katrina would be nothing more than a tiny pixel inside the Great Red Spot. The polar storms are trapped by the Coriolis effect, unable to drift towards the equator despite the turbulence around them. While Saturn has a single hexagonal wave, Jupiter has a cluster of cyclones, showing two ways nature makes geometry from gas. The diluted core remains the biggest puzzle. Was it a collision, or did Jupiter dissolve its own core over time? It is possible that the metallic hydrogen acts like a solvent, slowly dissolving the rock and ice core into the mantle. If this process continues, Jupiter might one day have no solid core at all, becoming a truly fluid planet throughout. Planetary protection rules are strict. We cannot risk contaminating a potential biosphere on Europa with Earth's bacteria. Some microbes are incredibly hardy and could survive the journey, potentially finding a home in Europa's warm subsurface ocean. Therefore, Juno must be destroyed to ensure that if we find life on Europa later, it is truly alien. For the team, Juno is not just a machine. She is a brave explorer who has exceeded all expectations. In its final moments, Juno will transmit data from within the atmosphere itself until the heat melts its antenna. Juno follows in the footsteps of the Galileo probe, which also ended its mission by diving into the giant in 2003. But Juno carries 21st century technology, promising to reveal much more about the upper atmosphere during its final descent. We have explored the cloud layers, from the ammonia ice on top to the water clouds and the crushing depths below. We have mapped the magnetic monster, discovering a dynamo that operates closer to the surface than anyone dared to predict. We have peered into the heart of the planet, finding a fuzzy core that tells a story of ancient cosmic violence. With nearly 100 moons and a massive magnetic bubble, Jupiter is truly a miniature solar system of its own. Since ancient times, this wandering star has inspired awe, named after the king of gods for its commanding presence. Now, thanks to Juno, we know it not as a god, but as a dynamic, evolving physical world of wonder. This mission is a testament to what humanity can achieve when we work together to solve the mysteries of nature. As we prepare to say goodbye to Juno, we celebrate the knowledge it has gifted us over these incredible years. The spacecraft may perish, but the discoveries it made will shine brightly in the annals of science forever. Imagine standing on Europa, looking up at this striped giant, knowing that a tiny machine from Earth is there. We are separated by hundreds of millions of miles, yet connected by our insatiable curiosity to understand our origins. Here at Dark Sky Dive, we are committed to bringing you the most detailed and accurate space documentaries on YouTube. What surprised you most about Jupiter? Was it the fuzzy core or the ammonia rain? Let us know in the comments. Share this video with your friends and family to help spread the wonder of the cosmos to everyone you know. A big thank you to our production team and researchers who worked tirelessly to put this comprehensive guide together. Tonight, go outside and look up. That bright wandering star is the world we just explored together. Thank you for watching. This is Dark Sky Dive signing off. See you in the next deep space adventure. Remember, the sky is not the limit, it is just the beginning. Keep looking up. Currently, we have covered the entire script. The remaining time is for you to enjoy the mesmerizing visuals of Jupiter.